Schaefer. I wanted to give you some helps and some information for the 4.05 discussion quiz on the nucleus of the atom. There is information that we've been covering on the review sheet, and you'll also find some very good information, help videos, and PhET simulations on the word wall. You can see a little snip here. These additional resources are going to be very helpful to you, along with some of the definitions. The first couple of questions we did in class was reviewing of the atomic mass and then also the atomic number. But before I get to that, I want to show you one. There is this PhET simulation here on the word wall that we could use to build an atom. And that will tell us if an atom is stable and neutral, along with what happens when we change the number of protons, neutrons, and electrons. And we do have some information here to help us. We have definitions of the atomic mass, some symbols, and also the atomic number. So we'll use that information right now to answer this question. So here is one type of picture of an element, and it says that we're going to assume everything's present. We have P's for protons, N's for neutrons, and E for electrons are also in different colors, blue, red, and yellow. And then it asks us, what is the atomic mass of this element? Well, we know from building our atom that we can figure this out. The electrons are there, and we learned in building an atom that the electrons really aren't used when determining the atomic mass or the atomic number. They're really important in deciding if something is neutral or not, and they're also used in bonding, which we'll talk about in the future, chemical bonds. So we learned that the neutrons can be different, and it's the same element. But if we change the protons, we change the element. So to determine the atomic mass, we're going to add the protons and the neutrons together. So we see 1, 2, 3, 4 protons and 5 neutrons. So 5 plus 4 is 9. The atomic mass is going to be 9. And then in this situation, it asks us the atomic number. Notice different question. It changes one word, the atomic number, but it's the same picture and even some of the same answers. So be careful in your reading. Read closely or carefully. So the atomic number, we know the atomic number is determined by the number of protons, and we see 1, 2, 3, 4 protons. So our atomic number is 4. Now we're going to apply this information to a couple of questions on the quiz. That means we need to count out the number of protons, the number of electrons, the number of neutrons, and then calculate the atomic number and mass. In this situation, this looks different. So we have to figure out, what are the electrons? What are the protons? What are the neutrons? Well, I know from back here that and in my build atom, it's pretty consistent about how we label them. We label them based on the charge. Electrons have a negative charge. So these negative dashes right there, those are the electrons. How many do we see of those? 3. Protons have a positive charge, so we can count those up. We see 1, 2, 3 protons. And then neutrons are going to be the 0 or no charge. 1, 2, 3, 4. Okay, so now we've calculated the number of protons, neutrons, and electrons. Next, we need to figure out the atomic number and the atomic mass. Use that word wall, use our helps from right here and right here to help answer those questions for you. This is a strip of some symbols and how to calculate and determine which is the correct symbol. So we have an atom that has 18 protons and 14 neutrons. We need to use the word wall to help us. Okay, so we know that there are 18 protons. What does the protons relate to? Okay, now how do we figure out the atomic mass? Because right here, my symbol says that atomic mass is in one location and atomic number is in one location, and the symbol, the element name, is in another. Now, we at this point don't need to know what these symbols are, but we do need to identify which one is the number and which one is the mass. And from there, we'll figure out which one of these answers is correct. So what you're looking for is, well, you can eliminate some of them just because of where they are stationed on this molecule. So here's a picture of the periodic table. We're going to talk about sulfur, which is right here. Atomic number 16, S. And we're given this situation: sulfur 32, sulfur 33, sulfur 34, and sulfur 36 are called what? So here we have a symbol of them. Oh, notice that relates kind of to this question right here, right there. We know proton number is 16. So there's that 32 means something else. What is it? I hope you figured out that it was the atomic mass. Or in this case, because here's the weight, the actual weight, they've calculated it out and how much percent is present. We determine the mass by the protons and the neutrons. So protons determines the element. So if the protons change, the element is not sulfur anymore. So what else affects that mass? And what are these called? Check out that word wall. What are these called? Here's some more specific information. Another picture. We have carbon 12 and carbon 14. See how they have 6 protons and 6 neutrons in carbon 12. In carbon 14, there's 6 protons and 8 neutrons. It's called carbon 12 because the total of protons and neutrons is 12. Carbon 14 because the total protons and neutrons is 14. And then it tells you the percent abundance. For the most part, 98.9% of all carbon that scientists find are going to be carbon 12. Less than 1% will be carbon 14. All right, so this question, which of the following isotopes, there's a word, what does isotopes mean, would have the greatest number of protons? I bet you need to know about isotopes. Okay, so which one has the greatest number of protons? Is it S32, S33, S34, S36? None, because they're all the same, or E, I'm still thinking about it. This is related to the essay question. Okay, and then think back to that build an electron or build an atom. Are the electrons different in S32, 33, 34, and 36? Okay, so all sulfur atoms must have 16 protons. So the answer in this case is D, none. They all have the same number. If this is a neutral atom, then the electrons are the same too. So in a neutral atom, all the protons are the same, all the electrons are the same. Now let's look at isotopes. We have 3 stable atoms of argon. argon 36, argon 38, and argon 40. What would the atoms of these isotopes have in common? What would be different about the atoms? Explain your answer. So in other words, what's the proton count? What's the electron count? What's the neutron count? And we are told that these are isotopes. What makes them isotopes? So go back and use this information that we answered before to help us determine how isotopes are different from each other. You can also use that word wall. Super helpful information. And notice that all of these questions are leading us to this answer right here, this essay question. So please be sure to list out how they are the same and how they are different, addressing the protons, the electrons, and the neutrons. I hope that helps you. Have a great day. If you have any questions, please let me know so that I can help you.